Hello, I am joined by Webb, the CSO of Pratt Whitney. How are you?
I'm very good, thank you. It's a pleasure to be here.
Good to have you. So tell us about the slogan, sustainability starts with the gear. What does that mean?
Yes, sustainability starts with the gear is associated with our revolutionary geared turbofan engine, which has a new technology called a fan drive gear system, a very high-powered, lightweight gear that is inserted in between the fan module and the turbo machinery. It enables the fan to turn slowly and the turbo machinery to operate at optimal speeds, and has delivered a 16% improvement in fuel burn and thus carbon dioxide reduction associated with the delivery of that engine into service in 2016. We actually have followed up with that in terms of our recent announcement with the Geared Turbofan Advantage, and that is going to enable us to insert some additional technologies which will provide an additional 1% improvement in fuel efficiency.
What is Pratt Whitney doing to support the development of aviation fuels?
Well, in our case, Pratt Whitney has been working with an organization called the CAFE. It's the Commercial Alternative Aviation Fuels Initiative. We've been working with them since 2006, developing different types of sustainable aviation fuel, shall we say, blends or feedstocks, and ensuring their compatibility with both the aero engines and the aircraft as a part of an overall government and industry coalition that has enabled us to release 7 different blend feedstocks that are available now today for use to reduce the overall carbon intensity of aviation. And we're going to continue to develop that with exerting that from beyond 50% blends, which are now currently available, to 100% or neat SAF. And we've recently tested our Geared Turbofan Engine Advantage with 100% SAF with no impact on operability or overall compatibility.
And what do you think of as hydrogen as a global solution to reaching net zero?
Well, hydrogen is a very important element, not only as a primary fuel source, but also as a feedstock for potential power to liquid fuels. So as such, we view the development of, first of all, green electricity to make green hydrogen as a key enabler for the aviation industry's total roadmap to net zero by 2050.
So tell us about HiSight.
HiSight, we're very excited about HiSight. This is a program that we were just recently awarded by the U.S. Department of Energy's ARPA-E organization. And what it is, it's a completely hydrogen fuel, so it's a zero-E emission, coupled with steam injection and intercooled turbine engine. And so with this, we're able to leverage the beneficial properties of cryogenic hydrogen to not only reduce the overall fuel burn and thus emissions generated from the engine by 35% current to today's standards, but also we're able to reduce NOx emissions, another greenhouse gas, by 80%. So we're currently working these technologies that are a very relatively low technology readiness level, and we are excited to have these develop, mature, and grow for the next generation single-aisle aircraft in the late 40s.
And tell us your thoughts on moving towards a net zero in 2050.
From what I can see today, the industry has coalesced together and is collectively moving in the direction towards achieving net zero. It's going to require a wide variety of shall we say, tools in our toolbox, and we are addressing all of those, from hybrid electric to the use of hydrogen fuels to the sustainable aviation fuels. A critical element of this is the ICAO General Assembly, which is coming up in September and October, in gathering that overall global alignment towards achieving the industry's commitment to achieve net zero by 2050.
And lastly, tell us about your hybrid electric projects as well.
Oh, we are so excited about that. We recently announced a hybrid electric demonstrator program in partnership with de Havilland and our sister division, Collins Aerospace, which is funded by the Canadian and Quebec governments. And in this case, what we're doing is we're coupling a high-efficiency thermal engine and a hybrid or a electric power plant, and also electric motor, generator, and also the associated drive systems. And this will enable us to have a 2 megawatt system that will provide about a 30% increase or reduction in overall fuel burn and thus emissions. We're doing this technology demonstrator in terms of a demonstrator ground test this year, and then we plan to flight test that in 2024. We're going to take these technologies and not only use it for our regional turboprop engines, which is where this initially is being developed, but we're going to scale it down for potentially APUs and also scale it up for application to our geared turbofan engines for the next generation.
Ambitious work. Thank you for your time.
Thank you very much.